Hi everyone, welcome to PrepFusion. So in this video we are going to study about digital filters. Now some people would be saying that sir, it is not in the syllabus. It was there previously in the syllabus but now it has been removed. But it is there in the syllabus. Digital filter is actually there in the syllabus. If they are saying that we are having DTFT and jet transform. If DTFT and jet transform is there in the syllabus, that means digital filter is also there in the syllabus. So whatever the kind of question that can be asked from digital filters, that we are going to study now. So we are not specifically going to design digital filters. We are not going to design it. Whatever the MCQs, whatever the MSQs, whatever the numerical type question can be asked from this particular topic in the GATE examination, those particular topics we are going to see. Okay. So don't completely skip it. You need to study it in a decent manner. But before watching digital filters, you should have the idea of analog filters as well, because I will be taking the reference of analog filters in this particular video. So what I have done, I have already uploaded a video which is named LTI system analog filters and sampling. You can type this particular thing, LTI system sampling by PrepFusion Himanshu Agarwal, or you can type analog filters by PrepFusion Himanshu Agarwal. You will get this particular video. Now this video is of 6 hours. In these 6 hours we are discussing everything. We are discussing about sampling as well, analog filters as well, LTI system as well. And surely at least 10 new things you are going to learn in this video. At least 10 new things. I can guarantee you. If you watch this particular video, even if you think that I know sampling, if you watch this video, you will get to learn 10 new things. Okay. But yeah, still if you don't want to watch it completely, at least watch from starting to 1 hour and 35 minutes. In a quick manner only you can watch. Like if you know that sir, if you think that sir I already know everything about analog filters, then you can go and in a very quick manner you can watch this particular video. Okay, you can watch this particular video in a very quick manner, like within 30 minutes or 40 minutes you can watch this particular video, and then if you find it interesting, then you can watch for complete 6 hours as well. So in these 6 hours we have covered LTI system, analog filters and sampling, everything. So it depends on you, but you need to have a basic idea of analog filters. Even if you think that I already know the basics of analog filters, still I would recommend that you watch it for 1 hour and 35 minutes. Okay, from beginning to 1 hour and 35 minutes, you watch it only for that particular window. Okay, in a quick manner you can watch it. And after that you will come to this video, and now we will start studying about digital filters. Okay, so this is the part of the course video only. So that course video part only I am adding up now. So now we are going to study about digital filters. Okay, yeah, so let's get started. Hi everyone, welcome to PrepFusion. So in this video we are continuing our discussion on discrete time Fourier transform only. So we need to study about filters first. We will study about digital filters, and then we will study about eigenvalue, eigenfunction. But before that, let's see some prerequisites, some basic concept we are going to see, that what if I multiply my sequence, what if I multiply my x of n with minus 1 to the power n. Then we will see what if I multiply my x of n with cos pi by 2n. So what will happen? What will happen to the frequency domain? So same kind of thing we have seen in continuous time as well. We were multiplying with e to the power j omega naught t, cos omega naught t, sin omega naught t. So what was happening? Shifting. So same thing will happen here as well. So let's check that. If I am multiplying with minus 1 to the power n, so what I can write it down as, what is minus 1? Is it e to the power j pi? Yes, minus 1 is e to the power j pi, because e to the power j pi is equals to minus 1. So can I write it down in this manner? Say yes or no. E to the power j pi n x of n. So let's write it down in a good manner. E to the power j pi n x of n. Do you remember the property? If x of n is having x e to the power j omega, then e to the power j omega naught n x of n, what it will have? Just the graph shifted by omega naught. Graph shifted by omega naught. If omega naught is positive, that means it will be shifted by right hand side, and if it is negative, then it will be shifted to the left hand side, right? So e to the power j pi n. So what will be your x e to the power j omega? X e to the power j omega, x e to the power j omega minus pi. That means whatever the center that was at 0, so it will be shifted. The center will be shifted to pi. Are you able to understand this point? So this is your x e to the power j omega, x e to the power j omega. So basically let's just call it x of omega only. And now you need to draw x of omega minus pi. What does that mean? That means you will shift it towards the right hand side. So now the waveform will be shifting towards the right hand side. So let's take an example. What you need to do? Sin pi by 6n divided by pi n. You know how to draw the frequency spectrum of this one. What you will say is that, sir, minus 1 can be written as e to the power j pi n x of n. So x e to the power j omega minus pi, e to the power j omega minus pi. So what kind of response you will get? The center is at pi. Previously center was at 0. If center was at 0, so this kind of waveform you are getting, minus pi by 6 to plus pi by 6, center being at 0, and then it was repeated with 2 pi, right? This was the thing that we were getting. Now center will be at pi. Now the center will be at pi. Center will be at pi. Center will be at pi. So pi by 6 backward and pi by 6 ahead, right? Center will be at pi. So pi by 6 backward and pi by 6 ahead. Seven pi by 6 and here 5 pi by 6, right? Now what will happen? It is periodic with 2 pi. So center is at pi. So pi minus 2 pi, what that would be? Minus pi. Basically it is periodic with 2 pi. That means pi plus 2 pi, pi plus 4 pi, pi plus 6 pi. In that manner it will keep on going. Along with that, pi minus 2 pi, pi minus 4 pi, pi minus 6 pi. So in that manner it will just keep on repeating, right? So similar thing is happening this side as well. So this center was at pi. So this point will be minus pi, right? Then it is periodic with 2 pi. That means the next center will be at 3 pi. Next center will be at 3 pi. Three pi plus pi by 6, 19 pi by 6, 17 pi by 6. Okay, and this point was minus pi plus pi by 6, and minus pi minus pi by 6, that would be minus 7 pi by 6. And same thing is happening towards the negative hand side as well. So did two similar thing here as well. Minus का 3 pi, minus 17 pi by 6, minus 19 pi by 6. So this would be your y e to the power j omega. Now just let me know one thing. What is our matter of concern? I told you one thing. Always our matter of concern is between minus pi to plus pi. And I will only look at the plus side, because I know that negative frequency doesn't matter. It is just to make sure that it is real or imaginary. So I will only look at the plus side. So what is this? This is the low frequency for me. This is the low frequency for me. And this is the high frequency for me. High frequency for me. Right? I told you omega equals to 0 is the low frequency and omega equals to pi is the high frequency. Right? And I am not looking at the negative side, because negative side is just symmetric. So I will only look at the positive side. In the continuous time as well, what we used to do? We used to see here only, and the same thing was happening this side as well. Right? So only the positive part I am going to see. So what I can see, the low frequency is not being passed. The low frequency is not being passed, but high frequency is being passed. Right? Here the gain is 1 and here the gain is 0. So what kind of filter it is? High pass filter. And here what was the scenario? If I say this is my minus pi and this is my plus pi. Minus pi, plus pi. This was low frequency and this was high frequency. So what you could see here, that low frequency is being passed, but high frequency is not being passed. Low frequency is being passed, but high frequency is not being passed. That means what it was? Low pass filter. So when you multiplied a low pass filter with minus 1 to the power n, it became high pass filter. If I say x of n is a low pass filter, and then I ask you what will be your minus 1 to the power n x of n, what will be your answer? Sir, it will be high pass filter for sure. Is that clear to you or not? And opposite process is also true. Opposite process is also true. What if I say that x of n is a high pass filter So what will be your minus 1 to the power n x of n? That would be a low pass filter. This opposite process is also true. This is also true and this is also true. So multiplying with minus 1 to the power n, what it will do? Convert low pass to the high pass to the low pass. You can do this process on your own. And directly you can see, no, this is a high pass filter, no. If I call this as y of n, that my y of n is a high pass filter. If I multiply with minus 1 to the power n y of n, what I will get? Minus 1 to the power n, minus 1 to the power n x of n. What will be the value of this one? It would be 1 only, because minus 1 would be plus 1 to the power n would be equals to x of n. So if I multiply my y of n with minus 1 to the power n, I am getting x of n. That means if you multiply your high pass filter with minus 1 to the power n, you will get low pass filter. And you can check as well, very easy. Just multiply this particular function with minus 1 to the power n. Then what it will happen? It will be shifted by another pi. It will be shifted by another pi. That means this minus pi will come to 0. This 0 will go to pi. This pi will go to 2 pi. That means this same waveform you will be getting again. So high pass filter is being multiplied with minus 1 to the power n. It will give you low pass filter. Is that clear to you? Very simple thing. Very, very simple thing. So this is one of the good conclusion that we have made. All good? All fine? So you don't need to mug it up. Even if you forget, in the examination you can derive it. You can follow the process. Very simple process I have told you. What will happen if you multiply with cos omega naught n? This process you should be doing on your own. Okay, do it on your own. So this x of n is given. I am multiplying with cos pi by 2n. Along with that, I am multiplying with 2 as well. Okay, I am multiplying here with 2 as well. Why I am doing so? You would have understood. So let's call this as x of n. So what we will be getting? 2x of n e to the power j pi by 2n plus e to the power minus j pi by 2n divided by 2. So this 2 and this 2 will get cancelled, right? So now what will happen? Y e to the power j omega, that will be x e to the power j omega minus pi by 2 plus x e to the power j omega plus pi by 2. That means shifted right, shifted left, and then added. Is that clear to you or not? Shifted right, shifted left, and then you need to add them up. So what I will do? I will shift it right by pi by 2. I will shift it left by pi by 2, and then I will add them up. So this center will move to pi by 2. The center will move to pi by 2. Pi by 2 minus pi by 6, pi by 2 plus pi by 6. So let's see what happens. The center will move to pi by 2. So pi by 2 plus pi by 6, pi by 2 plus pi by 6, 4 pi by 6, 2 pi by 3, and pi by 2 minus pi by 6, pi by 3. Okay. Now this center only will move to minus pi by 2 as well. This center only will move to minus pi by 2 as well. So what is happening? This center has moved to minus pi by 2. So this will move to minus pi by 6, minus pi by 2. Basically this point will move to minus pi by 6, minus pi by 2. So what it would be? Minus pi by 3. Basically minus pi by 2 minus pi by 6. 3 minus 2 pi by 3. Really sorry guys, it would be minus 2 pi by 3. Sorry guys, minus 2 pi by 3. And this point will be minus pi by 3. All clear? With the gain of 1. With the gain of 1. Next what will happen? whatever the center that we were getting here, this center, basically 0, this was 2 pi actually, this was 2 pi. So now this 2 pi center will be moved to minus pi by 2 and plus pi by 2. 2 pi minus pi by 2, 2 pi plus pi by 2, right? So both of the things will happen. 2 pi minus pi by 2, 2 pi plus pi by 2. So what will be 2 pi minus pi by 2? That would be 3 pi by 2. 3 pi by 2. So center will be moved to 3 pi by 2. And what will be 2 pi plus pi by 2? What will be 2 pi plus pi by 2? That would be 5 pi by 2. That would be 5 pi by 2. Basically, all the lobes, all these lobes will be having two clones at plus pi by 2 and minus pi by 2, plus pi by 2, minus pi by 2. This will also have plus pi by 2 and minus pi by 2. Basically, this is your minus 2 pi, no? So it will also have plus pi by 2 and minus pi by 2, right? So 2 pi plus pi by 2 and 2 pi minus pi by 2. So what will be 2 pi minus pi by 2? That would be 3 pi by 2. And what would be 2 pi plus pi by 2? That would be 5 pi by 2. Say yes or no, right? So here what you are getting, 3 pi by 2. Basically what is the width? 3 pi by 2 minus pi by 6. 3 pi by 2 minus pi by 6. So 9 pi by 6, 8 pi by 6, 4 pi by 3. Okay, and 3 pi by 2 plus pi by 6, 9 pi by 6. So 10 divided by 6, so 5 pi by 3, right? The width is actually pi by 3 only, so very easily I can find it out. Next, here what will happen? 5 pi by 2 minus pi by 3, 5 pi by 2 minus pi by 3. So what I need to do? 15 pi divided by 6, 5 pi by 2 minus 5 by 6 actually. 15 pi divided by 6, 14 by 6. So it would be 7 by 3. 7 pi by 3, and then plus pi by 3, that would be 8 pi by 3. So 5 pi by 2 plus pi by 6. Yeah. So this is the thing that is happening, and ditto same thing will be happening towards the negative hand side as well. And what will be this center? What will be this center? You can check the center of both of them. What that would be? It would be 2 pi only, no? Basically this center is 0. What will be this center? This center will be 2 pi only. This center will be 2 pi. You can check 5 pi by 3 plus 7 pi by 3 divided by 2. This would be the center. So what you are getting? 12 pi divided by 6. So this center will be 2 pi. What about this center? This center will be pi. 2 pi by 3 plus 4 pi by 3. 6 pi by 3. That is 2 pi divided by 2. So this center will be pi. So similar thing, whatever that I made here, the same thing will be made here as well. Now some people might be thinking that sir, periodicity got changed. Is that so? Do you feel like that periodicity got changed? No. See it clearly. This would be minus 4 pi by 3. This would be minus 5 pi by 3. What this would be 7 pi by 3. This would be minus 8 pi by 3, right? And this point will be minus pi. So between minus pi to plus pi, if you see, and what did I tell you? I will always look at the positive side only. I will always look at the positive side only. So what do you think? What kind of filter is that? I am looking only between minus pi to pi, and I will always look towards the positive side only. So here what I can see, low frequency is also not getting passed, and high frequency is also not getting passed. So low frequency is also not getting passed, high frequency is not getting passed, but mid frequency is being passed. What does that mean? It is a band pass filter. So process you can do on your own. Although in the examination, if this kind of question is coming and you want to follow the process, then what you will do? You will not make these lobes. I told you one thing, whenever you talk about DTFT, our matter of concern is always between minus pi to pi. So I will make this lobe only and this lobe only. I will get to know that, okay, my matter of concern is between minus pi to pi, my job is done. Is that clear to you? In the examination, I will never ever care about whatever that is happening after pi. So I will make this lobe and then I will get to know that, okay, there is no superimposition. Common part is not being superimposed. That means my job is done now. Between minus pi to pi only I need to make. I can see that low frequency is not being passed, high frequency is also not being passed, only the mid frequency is being passed. That means it is a band pass filter. So whenever you multiply your x of n with cos omega naught n or sin omega naught n, so this was a low pass filter. When I multiplied with cos omega naught n, this became a band pass filter. So don't mug it up, follow the process. Process is clear to you, then you will be able to solve all the question in the examination. So low pass filter, high pass filter, band pass filter, everything we have seen. We will see the notch filter as well, or you can say band stop filter. So band stop filter also we will see. So let's get started with digital filters. So let me know, what do you mean by low frequency in case of a discrete time, omega equals to 0, and what do you mean by high frequency, omega equals to pi. What is the value of z here? Z equals to 1. And what is the value of z here? Z equals to minus 1, because z equals to e to the power j omega. So omega equals to 0, z equals to 1, omega equals to pi, z equals to minus 1. And if I talk about mid frequency, that means you can put omega equals to pi by 2. Any day, if you feel like that, sir, I need to talk at mid frequency as well. So what you will do? You will put omega equals to pi by 2. It will be rarely used. It will be rarely used, but if you want to talk about mid frequency, then you can put omega equals to pi by 2 as well. And what will be the value of z at pi by 2? That would be j. Okay. So value of z would be j. So any day in any question, if you feel like that, sir, I need to talk about mid frequency, then you will put omega equals to pi by 2. What do you think? What kind of filter is that? Low pass filter, right? Because you know the frequency spectrum, minus pi by 3 to plus pi by 3, and then after that it will be repeated, but till pi and till minus pi, you can see that low frequency is being passed and high frequency is being stopped. So what kind of filter is that? Low pass filter. Okay. So a very rough diagram I can make, but in a good manner I will make it. Between minus pi to pi is my matter of concern, nothing else. Between minus pi to pi is my, sorry, this would be minus pi by 3 to plus pi by 3, but my matter of concern is between minus pi to pi. So this is a low pass filter. Now delta n minus sin pi by 3n. What is the frequency spectrum of delta n? That is 1, right? Frequency spectrum of delta n is 1. Basically what is happening here is that if I talk about B, okay, I need to add a page. If I talk about B, so B is given as delta n minus low pass filter, right? This is a low pass filter only, no? So delta n minus low pass filter. What is the frequency spectrum of delta n? The frequency spectrum of delta n is always 1, always 1. So from 1 low pass filter is being subtracted. So what will be the final answer? So here what will happen? 1 minus 1, here what was the gain? 1. So 1 minus 1, that would be 0. But here 1 minus 0, that would be 1. So between pi by 3 to pi, you will have something. And whatever that is happening after that, I don't care. I only care till pi only. So basically between minus pi by 3 to minus pi you are having something, and between pi by 3 to pi you are having something. That means what kind of filter is that? It is a high pass filter. So it is very obvious, no? From delta n, here your frequency spectrum was 1. From 1 you are subtracting something which is low pass filter. So what you will get? High pass filter only. Very obvious. And what will be your delta n? It will be all pass filter, right? All pass filter. It is passing everything. It is passing everything. It is all pass filter. What about this one? This was your band pass filter. right? This we have already seen. This analysis I spent so much time here just because this question would become very easy for you. So this would be your band pass filter, and what about this one? What about this one? This will be your band stop filter, or you can call it notch filter as well. Notch filter. Okay, because this is your band pass minus 1. So from 1 band pass is being subtracted. That means whatever that was being passed, that will not be passed, and whatever that was not passed, that will be passed now. Okay, so this analysis is good enough for you. You will get to know that this will become a band stop filter or notch filter. So what kind of response you will get for this one? This is your A, B, C, D, E. So for E, what kind of response you will get? You will get this kind of response, that it is a notch filter. That means it will pass everything, but it will block something in between. It will pass everything, but will block something in between. Passing everything, but blocking something in between. So this point is minus pi, this point is plus pi. Okay, so only the positive part I will see. Passes low frequency as well, passes high frequency as well, and you can see the frequency content as well. What is mentioned here? Pi by 6. Pi by 6. So, and here it is cos pi by 2. So center will move to pi by 2 minus pi by 6. Center would have moved to pi by 2 minus pi by 6, pi by 2 plus pi by 6. So this point will be pi by 2 minus pi by 6. So this will be 2 pi by 6 or pi by 3. And this would be 4 pi by 6 or 2 pi by 3. How did I get to know? Just draw the waveform of this one. Just draw the frequency spectrum of this one. First you will make the frequency spectrum of low pass filter. That means it will be there between minus pi by 6 to plus pi by 6, right? It will be there between minus pi by 6 to plus pi by 6. Then multiply with cos pi by 2. That means it will shift ahead, shift backward. So I made only one shift ahead. So the center will move to pi by 2. So this point will be pi by 2 minus pi by 6. This point will be pi by 2 plus pi by 6. So what do you understand by that? When you subtract it from 1, that means this part will not be passed. So which part is not being passed? Pi by 2 minus pi by 6, pi by 2 plus pi by 6. So center is pi by 2 only. Well and good. And here also in the negative side as well, the same thing will be happening. Okay, very simple concept. What about this one? What kind of filter is that? X of n is given. How will you solve it? How will you solve it? X of n is given where there is an arrow, that means that is the center. Basically this is n equals to 0. This is your n equals to 0 and this would be your n equals to 2. So what is your x of n? X of n is delta n minus 2 delta n minus 1 plus delta n minus 2, right? Delta n minus 2 minus 2 delta n minus 1 delta n. So what is your x of z? That would be 1 minus 2 z inverse plus z to the power minus 2. What is the low frequency? What is the meaning of low frequency? Low frequency means z equals to 1. So what is the value of x of z at z equals to 1? That would be 1 minus 2 plus 1, 0. And what is the meaning of high frequency? High frequency means z equals to minus 1. So value of x of z at z equals to minus 1. So that would be 1 plus 2 plus 1. If you put minus 1 here, minus 1 to the power minus 1, that would be minus 1 only, minus 1 to the power minus 2. Minus 1 to the power minus 1, that means 1 upon minus 1 to the power 1. So that would be minus 1 only. And minus 1 to the power minus 2, that means 1 upon minus 1 to the power 2, that would be plus 1. So plus 1 plus 2 plus 1. So answer would be 4. So what does that mean? High frequency is being passed, low frequency is not being passed. High frequency passes, but low frequency doesn't pass. What kind of filter is that? High pass filter. So this is how we need to analyze. Any x of n is given, you find out its z transform, then you know that low frequency is z equals to 1, e to the power j0 and e to the power j pi. E to the power j pi is z equals to minus 1. So low frequency, high frequency you put, you get your answer. This was your A. What about B? So what would be your x of z? Directly I will write x of z. So x of z would be delta n, sorry, 1 plus 2 z to the power minus 1 plus z to the power minus 2. Is that clear to you? 2 delta of n minus 1 plus delta of n minus 2. So 1 plus 2 z to the power minus 1 plus z to the power minus 2. So low frequency means z equals to 1. So x of z, you can clearly see that it will be passed. And high frequency means z equals to minus 1. So 1 minus 2 plus 1, because minus 1 square would be plus 1 only. So you can see that it is not being passed. So here what you can see, low frequency is being passed but high frequency is not being passed. What does that mean? It is a low pass filter. X of n as 1 0 minus 1, center is at minus 1. That means this is n equals to 0 and this is your n equals to minus 2. So what is your x of n here? Your x of n is actually minus delta n plus 0 delta of n plus 1, right? 0 delta of n plus 1, because it is in the negative side, and delta of n plus 2. Is that clear to you? Minus of delta n plus 0 of delta n plus 1 plus delta of n plus 2, 1 into delta of n plus 2. So what is the x of z you are getting? Minus 1 plus z to the power 2. Is that clear to you? Minus 1 plus z to the power 2. This would give you z to the power 2, this would give you minus 1. So at low frequency, if you check, so let's do it on the next page. So our C is x of z equals to minus 1 plus z to the power 2. Okay, so let's check at low frequency. Low frequency means z equals to 1. So x of z at low frequency is coming out to be minus 1 plus 1, that would be 0. And let's check at high frequency, that would be z equals to minus 1. So x of z at z equals to minus 1, what it is coming out to be? Minus 1 plus minus 1 square would be plus 1 only. That means low frequency is also not passing, high frequency is not passing. That means surely some mid frequency will pass, right? It is not always equals to 0. It is not always equals to 0, right? At some point it is equals to 0, at some point surely it will pass. Mid frequency will surely pass. Is that clear to you or not? Or you can check as well. You can check at mid frequency. Z equals to e to the power, what is the mid frequency? Omega equals to pi by 2. So what is z? E to the power j pi by 2. That means j. So z equals to j. So what will be your x of z at z equals to j? That would be minus 1 plus j square. That would be minus 1 minus 1. So the gain is minus 2. So yes, mid frequency is being passed. So what does that mean? What kind of filter is that? It is a band pass filter. And it is obvious as well, if you just checked at a low frequency and high frequency and you saw that it is not being passed, that means surely some mid frequency will pass. It is very obvious. You don't even need to check this mid frequency. It is very obvious that some mid frequency will pass. D 101. So can you write down x of z directly? Yes, I can write down x of z directly. So this is your n equals to 0, delta n, let's write down from x of n only. So what will be your x of n? X of n will be 1 into delta n plus 1 into delta of n plus 2, right? 1 into delta n plus 1 into delta of n plus 2. So what will be your x of z? 1 plus z to the power 2, right? Now what I will do? Z equals to 1 being passed. X of z at z equals to 1. Low frequency is being passed. At z equals to minus 1, high frequency is also being passed. If you put z equals to minus 1, what it would be? Minus 1 square, that would be also 2. So low frequency and high frequency is being passed. That means somewhere in between some mid frequency will not be passed. It is not all pass filter, right? It is not always equals to 1. Is it always equals to 1? No. It will be always equals to 1 only when z equals to 0. So no, it is not always equals to 1. That means it can be surely equals to 0 as well. This x of z can surely be equals to 0, no? 1 plus z square could be equals to 0. That means z equals to plus minus j. And what is the meaning of z equals to plus minus j? E to the power j omega, e to the power j plus minus pi by 2. So that means omega equals to plus minus pi by 2 frequency will not pass. Only this this frequency will not pass, which is omega equals to plus minus pi by 2, along with that plus minus 2n pi as well. Along with that plus minus 2n pi as well. Why is that so? Because it will be periodic with the 2n pi. So you can say that some mid frequency will not pass. That means I can put z equals to plus j or minus j. So what will be your x of z at z equals to plus j? That would be 1 plus j square. That would be 0. So low frequency, high frequency both are being passed, but somewhere in between some mid frequency is not being passed. What does that mean? That it is a band stop filter, or you can call it notch filter. Well and good. Let's go to the next one. So now you are going to draw the frequency response of practical filters. Only magnitude spectrum we are going to draw. So basically for low pass filter, what kind of response we saw? This kind of response we saw. That for low frequency it gives the gain of 1, and after that it gives the gain of 0. But actually practically you will never be able to design this particular thing. What I am saying, practically this will never be designed. That you cannot make any filter which will give you a constant gain of 1. That means any filter which is flat and then suddenly drops down to 0. So this flat and then this sudden decay, flat plus sudden drop, this is not possible. Practically you can never design this kind of flat response. So always what kind of response you will get? So I am first talking about analog filters. So what kind of response you will get? That at 0 frequency you are getting a gain of 1. But after that the gain will continuously decrease and slowly it will come down to 0. So gain will just keep on decreasing. So gain will just keep on decreasing. So this kind of filter you can practically design. Now sir, how to design this kind of filter? So that we will study in analog electronics and network analysis. So in analog electronics and network analysis we will design this kind of filters. So the thing is, practically you can never make this filter. If someone asks you what is the ideal low pass filter, then this is the ideal low pass filter. But practically you will never be able to make it. So this kind of filter you can make. And do you remember from where this kind of response would come? E to the power minus 80 ut. What was the response here? E to the power minus 80 ut. 1 upon j omega plus a, 1 upon under root omega square plus a square. So at omega equals to 0, the gain was 1 by under root a, and at omega equals to infinity, the gain was 0. So this is how it was decreasing. I hope you remember the magnitude spectrum. We draw this kind of magnitude spectrum only. Okay. So practically you can make these kind of things. Okay. But this you will never be able to make. From where you were getting this kind of a response? Sine 80 by pi t. Right? Sine 80 by pi t. Sine 80 by pi t. Can you draw the graph of sine 80 by pi t? Yes. This is your sine 80 by pi t. In time domain. In time domain, this is your sine 80 by pi t. Sine 80 by pi t. And can you draw e to the power minus 80 ut? Yes. This is my e to the power minus 80 ut. What is this? Sorry. What is this? Non-causal. And what is this? Causal. So all the practically non-realizable filters are non-causal. Whenever you see that there is a flat response and then there is a sudden decay, there is a flat response and then there is a sudden decay, that means practically you can never realize it. What do I mean by realize it? That means practically you can never make it. Practically you can never make this kind of filter. All the practically non-realizable system, all the system which you cannot make practically, those are non-causal systems, or you can say non-causal filter. And you can check as well. I gave you the proof. This was the ideal low pass filter. From where we were getting it? Sine 80 by pi t. So this was your sine 80 by pi t, which is non-causal. So ideally in the actual scenario, in the real world, you will never be able to get this kind of impulse response. This can never be your h of t. This is just an ideal way. This is just the ideal thing that you desire to have. So we want to go to near to this particular thing. We want to go to near to this particular thing, but we will never be able to reach to this particular thing. That means people want to go to the content of PrepFusion, but they will never be able to reach the content of PrepFusion. Right? They will never be able to reach this quality, but they will try to be near to PrepFusion's quality. So similarly, we will always try to be near to ideal. I am not saying we are ideal, okay? We also have some flaws. Everyone have some flaws. I was just kidding, nothing else. Yeah. So people will just try to, we will just try to go near to sin 80 by t, but we will never be able to reach it. So if I make some 3 or 4 diagrams and I ask you which of them is coming from, this is the frequency response I am drawing. This is the frequency response I am drawing, and I ask you which of them is coming from a non-causal signal. So what you will see, if you see any flat response or there is some decay, then you will see that surely it is coming from some non-causal signal. Is that clear to you? So this flat and then sudden decay, this is only possible from non-causal, and this kind of response are possible from causal as well. Although these questions will not be coming in the examination, but surely for knowledge purpose these are very helpful. So if you are making the notes, if you are studying from PDF, then somewhere you can write down these points, whatever that I told you. In the PDF only there would be enough space, you can write down here or on some back pages, here, anywhere you can write down. Or I will leave a page, I will leave this page for you guys. You can write down whatever that I told you here on the previous page. Here you can write it down. I will leave this page for you. Okay. Or if you are making your own notes, then you can surely write down anywhere you want. Yeah, so this was your low pass filter. So this we are drawing h of omega versus omega. So sir, how do we define the cutoff frequency? Sir, how do I define the cutoff frequency now? Because there the cutoff frequency was, it was giving a gain of 1 and then 0. So I could say that, sir, this is my cutoff frequency. Here what do I say? This is continuously decreasing, so where I can tell my cutoff frequency? So when the gain is 1 by root 2 times of the maximum gain. What is the maximum gain here? 1. So when the gain becomes 1 by root 2 times of the maximum gain, 1 by root 2 times of the maximum gain. So here maximum gain is 1. So at which frequency the gain will become 1 by root 2 times of the maximum? That is known as the cutoff frequency. Okay, that is known as the cutoff frequency. Although all these points we will again see in our analog electronics. In analog electronics we will again see these points, and then we will calculate these cutoff frequency as well, omega c, and these cutoff frequency omega c we will calculate. Okay, in case of analog electronics. In analog electronics we are again going to see these points. And what will be your high pass filter? So ideally high pass filter was like this, 0 gain and then 1 gain. But 0 gain will not be there. The gain will continuously keep on rising and then it will reach a maximum value. The gain will continuously keep on rising and then it will reach a maximum value. So this is what will happen. This is the response of a high pass filter. Okay. So this is your high pass filter. So only 0 gain you will be getting at omega equals to 0. After that the gain is just keep on rising up. So let's just say maximum gain is 1. Let's just say maximum gain is 1. So when you will have the gain as 1 by under root 2, the gain as 1 by under root 2. So this will be known as cutoff frequency. That means after this it will pass in a good manner. After this it will pass in a good manner, but before this it will give very lesser gain. Here also before this it will pass in a good manner, but after that it will give the lesser gain, because it is supposed to be low pass filter. So it should pass low frequency in a good manner and high frequency in bad manner. And here it should pass high frequency in a good manner but low frequency in the bad manner. So this kind of high pass filter response you will get. Okay, ideally we will get this kind of response. What about band pass filter? So this was the band pass filter, right? But ideally what will happen? The gain will keep on rising, right? What will happen? The gain will keep on rising. At some point it will provide you maximum gain, and after that the gain will keep on decaying. Here also the same thing, because the filter would be real only. So if the filter is real, the same thing will be happening towards the negative side as well. So the gain will keep on rising from 0. It will, here the gain will be 0, and here also the gain will be 0. At infinity as well the gain will be 0, but at some point it will reach the maximum. At some point it will reach the maximum gain. Let's just say I am calling the maximum gain as 1. I am calling the maximum gain as 1. So this is known as center frequency. What it is known as? Center frequency. Center frequency. Now when the gain becomes 1 by under root 2 times, 1 by under root 2 times here, and 1 by under root 2 times here. So when the gain becomes 1 by under root 2 times, so this is known as lower cutoff frequency and this is known as higher cutoff frequency, and this is known as, what this will be known as, bandwidth. Okay, bandwidth of a band pass filter. Omega h minus omega l, that will be the bandwidth of a low pass band pass filter, that I don't need to write, that you already know. So similar thing is happening towards the negative hand side as well. Similar thing towards the negative hand side as well. So omega center, this is minus omega L, this is minus omega H. So these are the practical filters that we are making. What about band stop filter? So band stop filter, initially it will provide the gain of 1, then the gain will keep on decaying, and at some point it will become 0, and after that it will keep on increasing, and then it will again become 1. Actually it will keep on increasing and at infinity it will become 1. What I mean to say is that it will provide a 0 gain and then it will keep on increasing and at infinity it will become 1, right? So this is how it will go. So again here as well the same thing will be repeated towards the negative hand side as well. And what was the scenario? This was the scenario in actual, right? Okay, so this is your band stop filter. Here also you can define lower cutoff frequency, higher cutoff frequency. So I am not going to write it down. You would know the same concept, right? Lower cutoff frequency, maximum gain is 1. So where will be the lower cutoff frequency? This will be the lower cutoff frequency. This will be the higher cutoff frequency. Right, and this is the maximum gain, which is 1 only. And what is the bandwidth of a band stop filter? What is the bandwidth of a band stop filter? The bandwidth is infinity always, right? Because it will pass infinite frequency content. So bandwidth is infinity for a band stop filter. All these basic points we have already seen. What about all pass filter? What about all pass filter? So the response of all pass filter will be like this only. It is practically possible. This is your mode of omega plus, this is your mode of h of omega versus omega. How it is possible? Just a simple wire. If I say here there is V potential, what will be the potential here? V. If I say here there is the square wave, so just a simple wire is there. So what will be the square wave here? That will also be the same only. Are you able to understand this point? So surely you can make any low all pass filter. What is the simplest all pass filter? Simplest all pass filter is a simple wire. That's it. It is a simple wire. This is the all pass filter. But the thing is, on a wire as well, if you go from one point to another point, on a wire, if I say here there is something and then here there is something. If I say here this is the Wien waveform and here also the waveform will be Wien, then it is not true. There will be surely some delay. What I mean to say is that Wien will surely take some delay to travel from here to here. If any signal travel across the wire, there will be surely some delay. You cannot say that, sir, there is a wire, this is a circuit, this is a circuit, sir, I apply Wien here and immediately it will reach here. Ideally, we will solve the problem in network analysis and in all the in analog electronics as well. We will solve the problem in this manner only, that I will apply Wien and at that time only Wien will reach here. Like there is no delay of the wires. But practically this doesn't happen. Every wire will have some delay. It cannot happen that no delay is there. Every particular wire will have some delay. Are you able to understand this point? Okay, and in the EMFT as well, we will deal transmission line. So there I will tell you what kind of delays would be there, why the delays will be introduced. So there I will discuss. But the thing is, practically always there will be some delay. So what do I understand by that? What do you understand by that? Let's just say a signal wants to travel from, this is the signal which is xt, and it wants to travel from here to here. So what will be your yt? Yt would be equal to xt only, but with some delay. Let's just say this square wave wanted to travel from here to this particular point. So what will happen? This particular wire will provide some delay. So here, this kind of waveform you will get, delayed waveform you will get. Is that clear to you or not? So what I mean to say is that practically what will happen is that xt, but your output yt will be x of t minus td. That means this I can call as x of omega, and this I can call as e to the power minus j omega td x of omega. This is my y of omega, right? So what is my h of omega? My filter is e to the power minus j omega td. And what is the magnitude of this filter? What is the magnitude of this filter? That is 1 only. Magnitude of this filter is 1 only, but there is some phase. So people would be thinking that, sir, why do we need all pass filter? Like all pass filter is doing nothing. It is passing all the frequencies. But all pass filter can be used to introduce some delay in particular signal. If I want my square wave to be delayed by some amount, so what I can use? I can use a all pass filter which will give me a gain of 1. That means this 1 should not be changed. This gain a and this gain minus a should not be changed. This waveform should also be square waveform only. Basically, the nature of this waveform should also not change. Amplitude should also not change. Nothing should change. Only thing I want is I want some delay. And if you want some delay, that means you can use all pass filter. Is that clear to you or not? So the use of all pass filter is that it will provide you some delay. The gain, keeping the gain as 1, or it could have any gain as well. It could have some gain a as well. But it will not change the nature of the waveform. If it was a square wave, then here also you will get the square wave only, but delayed by some amount or amplified by some factor as well. If it is having, let's just say, if it is having a gain of 3, that means your waveform will be amplified by a factor of 3, and it will be delayed as well. Is that clear to you? So this is the meaning of all pass filter, and this is how you can design it. So this kind of signal is surely possible, that it is always providing you a gain of 1. Okay. So all these points we are not going to write down, or in a short manner we can write it down. How we will write it down? That it is a all pass filter which is providing you a gain of, which is providing you a shift of td. This is x of t. It is giving a shift of td, and this is y of t. So y of t is x of t minus td. So y of omega e to the power minus j omega td x of omega. So your h of omega is e to the power minus j omega td. So your mode of h of omega is 1. Okay. So this is a kind of all pass filter only. Mode of h of omega is always 1. All good? All fine? Now digital filter, practical digital filter. What we are going to make? Practical digital filter. So what kind of practical digital filter you will see? That, sir, it will provide a gain for it at omega equals to 0, it will provide the maximum gain, and then it will keep on decaying. Then it will keep on decaying, and at pi it will become 0. Is that clear to you? Did you understand this point? Right? And similar thing is happening here as well. At minus pi it will become 0. Say yes or no. Similarly, now this will keep on repeating. And it is not necessary that it will become 0 only. It can have some value as well. Do you remember the response of a to the power n un? What kind of response you were getting? This kind of response you were getting. Right? This kind of response was there. At 0 there was some there was like, I don't remember, a upon root 1 minus a square was the magnitude, and here it was some magnitude was there, I don't remember. So the gain was not 0, but the point was that lower frequency are being passed with the higher amplitude, and higher frequencies are being passed with the low amplitude. low frequency being passed with a higher amplitude and higher frequency being passed with a lower amplitude. That means it is a kind of low pass filter only. Not ideal low pass filter, but a kind of low pass filter only, which is passing the lower frequency with a higher amplitude and a higher frequency with a lower amplitude. Okay. And now after that, what will happen is that it will just keep on repeating. It will just keep on repeating with the center at 2 pi. And in that manner, it will just keep on repeating. So this is your low pass filter. Similarly, make the high pass filter as well. What will happen? Lower frequency not being passed, higher frequency being passed. Lower frequency not being passed, higher frequency being passed. Right? And after that, what will happen? The same thing will be repeated. This is 0. The same thing will be happening at 2 pi as well. Around the 2 pi as well, the same thing will be happening. That means around center, from here, these frequencies will be passed and rest of the, and after that, basically whatever that is happening, this particular same waveform will be taking place around 2 pi as well. So minus pi will become plus pi, 0 will become 2 pi, and plus pi will become 3 pi. So this kind of response you will get. Yeah, in that manner. Okay, so this is your high pass filter. What about band pass filter? 0, and let's just say this is pi and this is minus pi. Band pass filter. So somewhere in between it will pass, and after that it will not pass. Sorry, somewhere it will band pass filter. Okay, sorry, band pass filter. Somewhere in between it will pass, and after that it will not pass. Somewhere in between it will pass, and after that it will not pass. Similar thing will be repeated. So this is your, only this much I need to see, that 0 and higher both not being passed, somewhere in between it is being passed, right? So if any kind of response is given, you will be able to tell whether it is band pass, band stop, all pass, whatever it is, you will be able to tell, right? Now band stop. Band stop. 0, pi, minus pi. Band stop means it will pass 0 as well, it will pass higher as well, it will pass 0 as well, it will pass higher as well. Okay, and then the same thing will be just repeated. This is what will happen is that this particular part will be repeated. So minus pi will move to pi only. Yes, this part will be repeated. And here also the same part will be repeated. I don't care about that particular part basically. You can just see I only care about this much part. That 0 is being passed, pi is also being passed, somewhere in between it is not being passed. And what about all pass filter? All pass filter will simply be one to the power n. What did I say? 1 to the power n? No, 1 to the power n is not a all pass filter. Really sorry guys, I should not have said 1 to the power n. 1 to the power n is not a all pass filter. What is 1 to the power n? It is a all pass filter or low pass filter, high pass filter, what it is? 1 to the power n. What do you think? Low pass filter, high pass filter, or what? Low pass filter, right? 1 to the power n. X of n is 1 to the power n. What will be x e to the power j omega? That would be 2 pi del omega, right? So only at omega goes to 0 you are having the impulse, then at 2 pi and then minus 2 pi. So 0, 2 pi, minus 2 pi. So between minus pi to pi, only 0 frequency is being passed. Between minus pi to pi, only 0 frequency is being passed. That means 1 to the power n is a low pass filter. Okay. So all pass filter will be simply what? Delta n. All pass filter will be delta n. Right. Or I told you about the delay. The same thing, delay. Just the delay. Here your x of n is there, and this will be x of n minus n naught. So e to the power minus j omega n naught x e to the power j omega. That would be equals to y e to the power j omega. So what would be your h e to the power j omega? That will be e to the power minus j omega n naught. And what will be its amplitude? That would be 1. So practically you will not be able to design delta n, but practically you can design a delay filter. You can just give a simple delay, right? So practically delta n is not possible, but surely a delay is possible. All good, all fine. So this is your all pass filter. Okay, so these were the practical filters that we wanted to make, and we have made it. Now let's see some question. X of n is given, y of n is given. You need to tell which is your possible h of n. So what do you think what is happening here? X of n was having two frequency component, pi by 3 and 2 pi by 3. Basically what was the frequency spectrum of x of n? You will be having an impulse at pi by 3, at minus pi by 3, at 2 pi by 3, and minus 2 pi by 3. And then the same thing will be repeated. Same thing will be repeated here. The same thing will be repeated with the center at 2 pi. So 2 pi minus pi by 3, 2 pi minus 2 pi by 3, 2 pi plus pi by 3, 2 pi plus 2 pi by 3. And similarly here as well, minus 2 pi plus pi by 3. In that manner it will just be repeated, right? So frequency components are pi by 3 and 2 pi by 3. But in the output only 2 pi by 3 frequency component is present. That means this has been eradicated. So you need to find that filter. You need to find that kind of filter which will kill this frequency spectrum, right? So what I will do, I will find h of h e to the power j omega in all of them, and then I will see that what is happening at pi by 3 frequency and what is happening at 2 pi by 3 frequency. Is that clear to you? So let's try doing it. So what is, let's check option A. We need to check the options. So in option A, what will be my h e to the power j omega? So where is the center? Center is at minus 1 by 2 plus you will get 1 by 2 e to the power j omega. 1 by 2 e to the power j omega. Basically what is your h of n? If you are not getting, if you are not understanding it, what is your h of n? My h of n is minus 1 by 2 delta n, right? Minus 1 by 2 delta n plus 1 by 2 delta n minus 1 plus 1 by 2 delta n plus 1. 1 by 2 delta n plus 1. This is your delta n minus 1. This is 1 by 2 delta n plus 1, right? So what you are getting? H e to the power j omega would be minus 1 by 2 plus 1 by 2 e to the power minus j omega plus 1 by 2 e to the power plus j omega. So you are getting minus 1 by 2 plus cos omega. This is your h e to the power j omega. Say yes or no for option A, right? H e to the power j omega. Now what you need to do? You need to check the gain at omega equals to pi by 3 and omega equals to 2 pi by 3. So h at omega equals to pi by 3. Pi by 3. H e to the power j pi by 3. That would be minus pi 1 by 2 plus cos pi by 3. That would be minus 1 by 2 plus 1 by 2. So you can see that it is providing a gain of 0. And this is what you wanted. Pi by 3 should be eradicated. So it is providing a gain of 0. But not only at pi by 3, you need to check at omega equals to minus pi by 3 as well. Why is that so? Because the input is having plus pi by 3, minus pi by 3, plus 2 pi by 3 and minus 2 pi by 3. Input is having the impulses at pi by 3 2 pi by 3, minus pi by 3 and minus 2 pi by 3. So you need to check everywhere. Okay, so what I will do is that I will just make the frequency spectrum of input as well, so that you don't get confused when you revise it. So what is my matter of concern? Always my matter of concern is between minus pi to pi. So between minus pi to pi, what all impulses you are having? At pi by 3, at 2 pi by 3, at minus pi by 3 and at minus 2 pi by 3. So I need to check at pi by 3 as well. I need to check at 2 pi by 3 as well. I need to check at minus pi by 3 as well, and I need to check at plus pi by 3 is minus 2 pi by 3 as well. Luckily what we got to know is that we are having cosinusoid here. So whatever that is happening at pi by 3, the same will be happening at minus pi by 3 as well. Because here if I put minus pi by 3, the same answer I will get. That means neither positive frequency is being passed, neither pi by 3 is being passed, neither minus pi by 3 is being passed. That means they are eradicated, they are gone. Let's check what is happening at 2 pi by 3. Now who knows, even 2 pi by 3 is not being passed. So if I check at 2 pi by 3, so what answer I will get? One thing is pretty sure, whatever that I will get at 2 pi by 3, the same I will get at minus 2 pi by 3 as well, because this is even, right? Cos omega is even only. So minus 1 by 2 plus cos 2 pi by 3. So minus 1 by 2 plus cos pi minus pi by 3 can I do? No. In the second quadrant, cos is negative. So here I need to add a negative sign as well. Oh, sorry guys, sorry. So 2 pi by 3 can be written as cos pi minus pi by 3. 2 pi by 3 can be written as cos pi minus pi by 3. So cos pi minus pi by 3, that means second quadrant. So what is the answer you are getting? What it would be? Minus 1 by 2, minus 1 by 2. So minus 1. Okay. So what you are getting at omega equals to 2 pi by 3 and minus 2 pi by 3. Your h e to the power j 2 pi by 3 is, that would be equals to h e to the power minus j 2 pi by 3, that is equals to minus 1. This is the scenario you are getting. So the gain is minus 1. So first answer should be there, right? No. Because the gain is minus 1, no, not plus 1. Basically what you got to know that pi by 3 and minus pi by 3 is cancelled. But the component at 2 pi by 3 and minus 2 pi by 3, that will be multiplied with minus 1. So what would be your output? Minus cos 2 pi by 3n. Are you able to understand this point? What I mean to say is that filter of AHN, if I apply and my applied input is cos pi by 3 plus cos 2 pi by 3n, then what will happen is that this component will pass. Yeah, nothing. Yeah. So what will happen is that this component will not pass, but this component will pass, but with the gain of minus 1. With the gain of minus 1. So what will be the output? Output will be minus cos 2 pi by 3n. This will be the output, not this output. But you need the gain to be plus 1, right? Not minus 1. So this is wrong. Understood? Okay. So this was the beauty of this question, that people will feel that okay, this is not being passed and this is being passed, so this is the answer. But here minus should have been multiplied, which is not multiplied here. So provided gain is minus 1, not plus 1. What about the next one? Minus 1 is there. So directly I am writing down h of z. This would be n equals to 0. This would be n equals to 2, and this would be n equals to minus 2. So what will be your h e to the power j omega? Minus 1 plus e to the power j2 omega plus e to the power minus j2 omega. So what you are getting? Minus 1 plus 2 cos 2 omega, because multiplied by 2 divided by 2. So this is your h e to the power j omega. Again let's check where we will check at omega equals to pi by 3 and 2 pi by 3. Again you can see that it is even only. If I check at pi by 3, so what is the value of cos 2 pi by 3? That I saw here only. It is minus 1 by 2. Cos 2 pi by 3 is minus 1 by 2. Minus 1 Okay, it is gone here only, minus 2. So you don't even need to check at 2 pi by 3, because you know that even pi by 3 component is not being cancelled, right? We are understanding this point, right? Or I did something different. Did I do anything wrong? No, minus 1 was there, 1 was there. E to the power j2 omega, e to the power minus 2j omega, e to the power plus 2j omega, and e to the power minus 2j omega would come, right? So 2 cos 2 omega. 2 cos 2 omega. When I check at pi by 3, what is the response I am getting? 2 into cos 2 pi by 3. What is the value of cos 2 pi by 3? That is cos pi minus pi by 3. Cos pi by 3 is 1 by 2. So minus 1 by 2. So minus 2. You don't even need to check ahead now. You don't even need to check at 2 pi by 3, because you know that this is also getting a gain of minus 2. So let's check what? Let's just check. So if we are checking, what we go to know? That minus 1 plus 2 cos 4 pi by 3, right? 2 cos 2 omega. So even in the fourth quadrant, it is negative only. So same thing you are getting. The value of cos 2 pi by 3 and value of cos 4 pi by 3 is same only, right? Both is minus 1 by 2. So basically you are getting gain of minus 2 only. At both of the frequencies you are getting the gain of minus 2 only. So what would have been your output? Your output would have been whatever the input is there, that being multiplied with minus 2 plus cos 2 pi by 3n, right? So these frequencies are just being multiplied with the gain of minus 2. So even option B is wrong, right? What about this one? Can you make the response of option C? Yes, surely I can make the response of option C. So for the response of option C, I can surely make. So you know that all of the above cannot be the answer. So this has to be the answer. Option C has to be the answer. And surely I can see that it is a band pass filter, right? Band pass filter. Here you can see that sine pi by n, sine pi by 6n divided by pi by n. This would have given this kind of response. Minus pi by 6 to plus pi by 6. Now what will happen? The center will move to 2 pi by 3. The center will move to 2 pi by 3. So center will move to 2 pi by 3. Center will move to 2 pi by 3. So 2 pi by 3 minus pi by 6. 2 pi by 3 minus pi by 6. So that would be 4 pi by 6 minus pi by 6. That would be pi by 2. Right? Pi by 2. And plus pi by 6. So that would be 5 pi by 6. So basically which component is being passed? Here 2 pi by 3 component will pass with the gain of 1. Here the gain of 1 would be there because 2 is being multiplied, no? So gain of 1 would be there. And here also this point will be minus 2 pi by 3. And this point will be minus pi by 2. And this point will be minus pi by 6. So gain of 1 would be passed. So basically 2 pi by 3 and minus 2 pi by 3 will be passing with the gain of 1. And here will be pi by 3. Because this is 90 degree, pi by 3 is 60 degree. So pi by 3 would be somewhere here. And minus pi by 3 would be somewhere here, right? So this is your h e to the power j omega. So when you write down the output, you don't see at the mode. This is not you want to see. This is what you want to see. So this is the scenario. What is the scenario? That 2 pi by 3 component is being passed with the gain of 1, and pi by 3 and minus pi by 3 components are being passed with the gain of 0. So this will be the correct answer. If you pass your x of n with this filter, then you will get the correct answer. Well and good. Okay, so answer option C would be there. So concept of eigenvalue and eigenfunction now we want to study, because we have seen the concept of filters in a very good manner. So I will take a pause and then I will come back. We will start studying about concept of eigenvalue and eigenfunction. Okay, and let's take another point. What is the point? That your x of n is 1 to the power n. What kind of filter is that? And if your x of n is minus 1 to the power n, what kind of filter is that? So what is 1 to the power n? If you make the diagram, you will know what kind of filter is that. You know surely it is a low pass filter. But if you make the diagram, This is your 1 to the power n, right? 1 to the power n. So always 1 1 1 1, always 1 1 1 1. 0 1 2 minus 1 minus 2. It is always 1. This is your x of n. X of n versus n. And what is x e to the power j omega here? That is 2 pi del omega. If I talk about only between minus pi to pi. If I only talk about between minus pi to pi. What does that mean? That means only omega goes to 0 passed. Right? At omega goes to pi is not passed. Only omega goes to 0 is passed. Rest all the frequencies are not passed. That means it is a low pass filter. Low pass filter. And you will call it the best low pass filter, because it is only passing the 0 frequency. What is the use of low pass filter? That it should pass low frequencies. It is passing only the 0 frequency, which is the lowest frequency. After that, it is not even passing. So your time domain signal x of n is not rapidly changing, no. It is always 1. So time domain signal is not even changing. If your time domain signal is not even changing, or it is changing slowly, that means it will be kind of low pass filter. It will be near to the low pass filter. Let's just say if I make, or let's just explain about minus 1 to the power n. So what do you think? What kind of filter would be minus 1 to the power n? Can you write down? One thing you know, that if your x of n, if your 1 to the power n is being multiplied with minus 1 to the power n, that means if your x of n, which is a low pass filter, if it is being multiplied with minus 1 to the power n, then it will become a high pass filter. So surely it will be a high pass filter. And how you can check? Right? Say yes or no. Right? So 1 to the power n has 2 pi del omega. So what this will have? This will have 2 pi del omega minus pi. And similar thing at minus pi as well. So omega plus minus pi. 2 pi del omega minus pi. 2 pi del omega minus pi would be there. 2 pi del omega minus pi would be there. So basically it will have an impulse at pi. But it should be periodic with 2 pi, no? So periodic with 2 pi, that means pi minus 2 pi, another impulse you will have here. At minus pi as well you will have the impulse. So between minus pi to pi it will have these impulses. That means it is passing the highest frequency only. So that means only omega equals to pi is being passed. Only omega equals to pi is being passed. That means it is a high pass filter. So let's make x of n. So if I make, or let's call this as y of n. Let's call this as y of n. So if I make the diagram of y of n. So here what is the scenario? At n equals to 0 you will get plus 1. At n equals to 1 you will get minus 1. At n equals to 2 you will get plus 1. Then minus 1, plus 1 and minus 1. And similarly here as well. Minus 1, plus 1, minus 1, plus 1, and so on. Right? N equals to 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So what you can see? X of n was changing. It was not even changing. Forget about changing rapidly. It was not even changing. It was always 1. But this is changing rapidly. 1, minus 1, 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 1, minus 1. So if your time domain signal changes rapidly, that means there will be more of a high pass nature. And if your time domain signal becomes, if it changes in a less rapid manner, that means it will have a low pass nature. What I mean to say is that, let's just say I make two kind of signal. I make this kind of signal. So 3, 2, 1, and then 0. Then again the same thing is being repeated, or this kind of signal is there. Basically this is the signal, that's it, nothing else. And another signal is this 3, 2, 3, minus 2, plus 1, 3, minus 2, plus 1. So which will have more high pass nature? What I want to say, which is a better high pass filter? Which is a better high pass filter? What will be your answer? this is a better high pass filter because it is changing more rapidly. And if I ask you which is a better low pass filter, then this would be the answer, better low pass filter. So if your time domain signal changes more rapidly, that means it is near to the high pass filter. That means it will show the high pass filter in a better manner. It will show the nature of high pass filter in a better manner. And if it changes slowly, that means it will show the nature of low pass filter in a better manner. So all these points are like very, very deep points. Okay. In the GATE examination till now, these points are not introduced. So that's why I thought that if someone asks you, even in the interview, if someone asks you about low pass filter, high pass filter in the discrete domain, in the digital domain, then this is how you can tell. 1 to the power n, what is the meaning of minus 1 to the power n? I hope you understood the importance of minus 1 to the power n, and now you have understood the importance of 1 to the power n as well. Right? So minus 1 to the power n can change from low pass to high pass, from high pass to low pass as well. And minus 1 to the power n means it is very rapidly changing, very fast, rapidly changing. That means it is only passing the omega equals to pi frequency component. Omega equals to pi frequency component only. Is that clear to you? All good, all fine. So now we are going to study about concept of eigenvalue and eigenfunction, which is nearly the same that we study in continuous time. So nearly the same kind of a concept would be there. Okay, well and good. Thank you very much. And more questions on digital filter we will see in this video only. Like here I will add up more parts. So in some questions we will see more questions we can see on the concept of digital filter. Okay, yeah, thank you. Yeah, so let's see this question on filter. Very simple question. Basically a block diagram is given. So how to read this block diagram? X of n is there. So x of n will come here. It will be multiplied with 5. So what you will get here? 5x of n. X of n will be multiplied with 5. Here what is written? Unity delay. That means x of n, it will go here. Unity delay means here you will get x of n minus 1. Then another unity delay. That means you will get x of n minus 2. Okay, delayed. X of n minus 1, x of n minus 2. Whenever they talk about delay, you will do right shift. X of n minus 1, x of n minus 2. Unity delay, then another unity delay. So delay by 2. And then what will happen? This will come and it will be multiplied with 5. So 5x of n minus 2. Now what is your y of n? So in y of n you will say that, you can see that this will be multiplied with plus sign. And this will be multiplied with a negative sign. So this is your y of n. So y of n, 5 of x of n minus 5 of x of n minus 2. You need to find the type of filter. So how do we find the type of filter? With h e to the power j omega only. So my target is to find h e to the power j omega. So y e to the power j omega is equals to 5x e to the power j omega minus 5 e to the power minus 2j omega x e to the power j omega. Right? Shift is there. So you know that you can apply the property e to the power j omega n naught. Value of n naught is minus 2. So y e to the power j omega divided by x e to the power j omega, that would be equals to h e to the power j omega, and that will be equals to 5 into 1 minus e to the power minus 2j omega. And why do I need e to the power j omega? Why should I carry e to the power j omega? I should have carried with h of z only, no? Why do I do h e to the power j omega? So let's write down h of z only. Needlessly I did all this calculation. So basically it would be 5 into 1 minus z to the power minus 2. Say yes or no, right? Z to the power minus 2. Now low frequency and high frequency. So at low frequency if I check h of z at low frequency, so what I am getting? 0. And h of z at high frequency, what I am getting? Again 0. Right? H of z at low frequency and h of z at high frequency as well, because minus 1 to the power minus 2, that would be plus 1. So low frequency, high frequency I am getting 0. So somewhere in mid frequency I will be getting some gain, and you can check at h equals to j, sorry, z equals to j. So if you put z equals to j here, what you are getting? 1 minus j to the power minus 2. So that would be 10, because j to the power 2 would be minus 1. So it would be 10. So yes, mid frequency is being passed, low and high frequency is not being passed. What does that mean? It is a band pass filter. So very easily you can solve these kind of questions. So just write down the h of z or h e to the power j omega, whatever you want to write down. So here I would have put omega equals to 0, omega equals to pi, and then I would have put omega equals to pi by 2. One thing I saw that low frequency, high frequency both are not being passed. That means surely some mid frequency will be passed. Surely it will be a band pass filter. So two terms can be introduced in your examination. It could be written FIR filter or it could be written IIR filter. So what is the meaning of FIR? FIR means finite impulse response. Finite impulse response filter. Impulse response. And IIR means infinite impulse response. Infinite impulse response filter. Okay. What do you mean by that? That means number of samples will be finite. H of n has finite length. That means number of samples will be finite. Samples will be finite. It can have 1 sample, 2 sample, 3 sample, 4 sample, 1000 sample, 1 lakh sample, 2 lakh sample, but number of samples will be finite. And here number of samples will be infinite. That's it. So if I write down my h of n as, h of n is 1, 2, minus 1, 3, minus 2, 1 by 2. Okay, this is your h of n. So this is a finite length. No? 1, 2, 3, 4, 5, 6. 6 samples are there. So finite length. So it is a FIR filter. FIR. Okay, FIR system or FIR filter, whatever you want to call it. And what about IIR? Just a to the power n un. Or h of n equals to un only. Or h of n equals to sin omega cn upon pi n. So you can see that value of n can go from 0 to infinity and it can go from 0 to minus infinity as well, or minus infinity to 0 as well. Basically here what is the length? Infinite length is there, no? So how many samples are there in h of n? A to the power 0, a to the power 1, a to the power 2, a to the power 3, a to the power 4, a to the power 5, till a to the power 100, a to the power 1000, a to the power 1 lakh, a to the power 1 crore, a to the power infinity. So infinity samples are there. Same goes for un as well. 1, 1, 1, 1, 1, 1. It will be repeated for infinity times. And sin omega c by pi n, this kind of graph you will be getting. This kind of graph like decreasing, and then basically this kind of graph. It is continuous I am making, but just sample it. This is the continuous I have made, but if you sample it, then this kind of graph you will be getting. So here also infinite samples are there. So all these are IIR. Okay, so if you see these names, you should not be getting confused. Sir, what is IIR? What is FIR? So this is the meaning of IIR and FIR. You can see one of the question. So h of n is given, h of 2 is equals to 1, h of 3 is equals to minus 1, and h of k is equals to 0 otherwise. So basically this is your h of n. H of n is only non-zero things are 1 and minus 1. 1 and minus 1. So this is your n equals to 2 and this is your n equals to 3. Rest all are 0. Rest all are 0. So this is your h of n. So is it FIR? Surely it is FIR. Finite impulse response. Is it low pass or high pass? Low pass, high pass, band pass, whatever it is. So let's check that. So what is your h of n? Your h of n is delta of n minus 2 minus delta of n minus 3. So z to the power minus 2 minus z to the power minus 3. So you check at low frequency. At low frequency if I check 0, and if I check at high frequency, so this will give me 1, but this will give me minus 1, because minus 1 to the power minus 3 will be minus 1 only. So high frequency is being passed, so it is a high pass filter. Okay, so it is coming out to be a high pass filter. So this statement is wrong. So very easily we can solve this question. Well and good. Okay.